A recent change in the energy scene is that they take used frying fat and vegetable oil like soybean oil and safflower oil and make it into diesel fuel. They call it biodiesel. I think this tells us something about the structure of fats. Fats are hydrocarbons. They're simple hydrocarbons. And if biodiesel and regular diesel were mixed together, they would come out together in the first fractionation. The fraction that has regular diesel will also have the biodiesel. They're both high energy. High energy in fat is not exactly the same thing, but it's also not entirely different. Calories per gram could be compared to miles per gallon in a diesel truck, I think. So let's do side-by-side comparison. Diesel fuel and biodiesel. Diesel is about C12 to C16, and biodiesel is bigger. Biodiesel is C16 to C22. Biodiesel is straight chains. Biodiesel it's made out of derivatives of fatty acids, and they're straight chains, and there's no exceptions to that. Diesel is branched, and there would be exceptions to that, but the great majority of the diesel fuel molecules are going to be branched. Diesel fuel does not have a lot of double bonds. You can't say it doesn't have any, but double bonds are something that come about through biological systems and other ways, but diesel fuel is definitely not dominated with double bonds. Biodiesel has lots of double bonds, mostly double bonds, in fact, and that explains the discrepancy that biodiesel with bigger molecules has the same boiling point because a lot of the molecules in biodiesel have double bonds. And then regarding the biodiesel business, biodiesel is oxygenated. They take the fatty acids and turn them into methyl esters, which are oxygenated just a little bit. And then diesel fuel is very much not oxygenated, so that a truck on biodiesel will not get quite as good a gas mileage as a truck on regular diesel fuel. And then the final comparison would be that diesel fuel is a natural product, and there's contaminants in the diesel fuel. The contaminants being sulfates and nitrates and perhaps some heavy metals. Biodiesel doesn't have any of that. So biodiesel will actually burn purer, burn cleaner, but perhaps not get quite as good a gas mileage as regular diesel fuel. Fats and lipids. Let's lay a little groundwork for our quick survey of this subject. Fatty acids, we have the length of the fatty acid and then the degree of unsaturation. Let's start with the length. Fatty acids, they come in C16, C18, C20, C22. Notice that they come in even numbers. Fatty acids in biological systems always come in even numbers. And the reason is simple. They are made 2 at a time and degraded 2 at a time. So it's 2 plus 2 plus 2 plus 2 plus 2 and 2 minus 2, 2 minus 2 minus 2 minus 2. They're always made, they're catabolized and metabolized 2 at a time, and they come in even numbers. And the unsaturations have a big impact on the behavior of the vegetable oil. That is to say that as the fats become unsaturated, the boiling point goes down. Unsaturated means liquid. Saturated means solid. Polyunsaturated refers to vegetable oil. Partially hydrogenated or hydrogenated vegetable oil refers to like margarines and Crisco and things like that. Let's go straight to these examples. We have C18, C20, and C22. Notice they have even numbers. So monounsaturated, where does the first double bond go? The first double bond goes, counting from the methyl end, goes between the 9 and the 10. They call it the omega 9. So between this one and this one, and it's the same for the C18, the C20, and the C22. It goes in the same place relative to the methyl end. And then the second double bond goes between the 6 and the 7, which is called the omega 6. And then the third double bond goes between the third and the fourth. This is called the omega 3. And these three unsaturated fatty acids would all three be liquid. The structure of fatty acids is not arbitrary. They are made in plants, and the large, more unsaturated fatty acids are not made in animals. The omega-3 fatty acid cannot be made by humans. Polyunsaturated fatty acids are not very stable. The double bonds are thermodynamically unstable. Oil with a lot of double bonds will spoil and go rancid. Foods made with unsaturated fatty acids does not have a good shelf life. The process of hydrogenation lowers the boiling point, making the oil more solid and more predictable. It also stabilizes the final food product. Hydrogenation is a random process and results in no predictable pattern in the fat material. Let's end with this structure. It's called docosahexaenoic acid. Notice it has a 3, 6, 9, 12, 15, 18 unsaturation. This is referred to as super unsaturated. The double bonds make planar structures, but they are methylene interrupted such that they can rotate independently. The double bonds are all cis. This is a rule in biology, is that the double bonds are always cis. The cis bonds make a lot of kinks in the otherwise straight chain. And this, of course, leads to the fact that these materials are liquid. They don't pack together very well. This compound is not made by human metabolism, and docosahexaenoic acid is added to baby formula as a nutritional supplement. And that's it.